Today I'm here to talk about my book, And in the End, which I wrote I published a few months ago. It took about 5 years. It was 5 years in the making and writing it. This book is the retired DGP, Mr. Chaudhary, said that fact is often stranger than fiction. That's absolutely true. This book is about quantum physics and it's about astrophysics. And here you'll find the universe. It is not only strange, it is stranger than you can even imagine. So I'd like you to just sit back, relax. How much time do I have for the next 15 minutes? To take you on a wonderful, magical, fabulous, mystical journey through quantum physics and astrophysics. Quantum physics is the stuff which is very, very, very small. Astrophysics is the stuff which is very large. I have to confess that I'm not an astrophysicist, neither am I a quantum physicist. I studied history. I studied history right here in Presidency College. But studying the liberal arts, it gives you one advantage. It gives you the power of creativity, gives you the power of imagination. And even Albert Einstein, before he came out with his famous equations and his theories of relativity, he used to imagine. He used to imagine himself in a certain situation, like sitting on top of a sunbeam and watching another sunbeam coming from the other direction and then trying to calculate the speed of light. So this book is going to take you into concepts which are very difficult to wrap your mind around because a lot of it is counterintuitive. Because the laws of evolution have determined that our brain can only operate on a median level. We cannot visualize the very, very small, we cannot visualize the very, very large, which is fair enough actually, because evolution has a point. That evolution is more concerned about your survival rather than your own personal survival, the survival of the species. So therefore it is important to not clutter your brain with too much stuff which is not essential for your survival. But being curious, being human, we are curious about our origins, we are curious about our destiny, we are curious about where the universe originated, where we originated. So that is why we need to go on to quantum physics and astrophysics. Because please understand that you are very closely integrated with the universe. You are literally made of stardust, you're literally made of star stuff. We are all children of the stars. Because if you take a supermassive star, which then explodes with tremendous violent force called supernova, it spreads all its material, everything that you're made of hydrogen, oxygen, and all your trace elements, silicon, and all the carbon molecules, which later on sort of congealed together and created life. So we are children of the stars, and what happens in the universe influences us in many ways, which we don't even understand. So this book I've made a novel. It's an unusual book that way, because normally you get more textbooks than novels, on fiction, on subjects like quantum physics. And it's also unusual in the sense that even though it has been given the genre of science fiction, but by all accounts, the book is about 85% science and 50% fiction. Like you said, sir, stick to the facts because facts are stranger and more wonderful than fiction. So in the book I touched upon concepts like black holes, multiple dimensions, extraterrestrial intelligence, dark matter, dark energy, and time, space, which has again reiterated is all very strange. So I'll just speak about it briefly. Now, you take the concept of multiple dimensions. We're familiar with the normal three: length, breadth, and height. 3 dimensions. Now it's difficult to imagine a 4th spatial dimension. It's difficult to imagine a 5th spatial dimension. It is impossible to imagine. But the maths have shown that there are at least 26 dimensions. And you must understand mathematics. I'm not a mathematician myself, but mathematics seems to be the language of the universe. And whatever first has been proven on the blackboard using mathematics has later on been proven empirically once the instruments are sophisticated enough to prove it. So maths has shown that there is a theory called the string theory, 26 dimensions. So we cannot imagine 4 dimensions. We can't imagine 26. But you can imagine 2 dimensions. You can imagine something totally flat, absolutely flat. Where you got length and breadth and absolutely no depth. And there is a flat world. And in that flat world, there are flat people, like shadows. The shadows have only got 2 dimensions. And let us call these flat people flatlanders. Now suppose you, a creature of 3 dimensions, goes and hovers over this flat land. You can throw things at, you can throw rocks at these flat people. You are there, totally flat. Imagine no depth. You are on top. So you can, in a helicopter perhaps, hover over it, throw things at it, and it won't know what's happening. And you can start talking. You'll hear a voice coming from somewhere, but it will be a totally disemboweled voice, which you won't understand. It's because they cannot visualize 3 dimensions. So even there might be somebody from the 4th dimension or 5th dimension sitting next to you right now who can interfere in your life, but you will be unaware of it. So that brings me to the other point of extraterrestrial intelligence. There was a scientist called Frank Drake who died about a month ago. So he came out with a famous equation called the Drake equation, which basically means taking just one galaxy, our galaxy, the Milky Way, which is estimated to be about 400 billion stars. And you have to get used to the numbers, millions and millions, billions and billions, trillions and trillions, because the universe is, like I say, infinite. So just take our one galaxy, the Milky Way. So then the number of stars which have planets, and how many of these planets can develop life, how many of these places which have planets which have life can become intelligent life, then what fraction of these can develop communication, etc. So even if you take a very, very small average, there will still be billions and billions of planets which have life. Now, we've recently sent up some space telescopes. Earlier it was the Hubble, then it was the Kepler, and now it is the James Webb telescope, which has discovered thousands and tens of thousands of exoplanets which might be harboring life. So there is life out there, there's life. And they'll be technologically much more advanced than us. But the question is, we're not being able to contact them. So therefore, so on, we have got various organizations like SETI, the Search for Extraterrestrial Intelligence, etc. And a lot of scientists say before the decade is over, thanks to the James Webb telescope, we'll be able to find life on other planets, which could be technologically far more advanced than us. And there was a physicist, astronomer called Carl Sagan. So Carl Sagan, he had a doubt. He had a theory that the moment a civilization reaches a certain technological level, that civilization has to self-destruct so that it doesn't contaminate the rest of the universe. So then maybe we have reached that technological level to self-destruct. Either we are self-destructing in terms of climate change, or if you see what's happening in Ukraine and a constant threat of using nuclear weapons. So maybe that technological level has been reached where we have to self-destruct. So anyways, we also have this trying to understand what happens when there's a black hole. Black hole, it stretches time and space. It's called the fabric of time and space. So you've got to imagine time and space like a bed sheet which is held tightly by 4 people in the corner, held very tight. So you take an object, let's say you take a metal ball and put it in the bed sheet. So then the sheet is bent, time and space gets bent. And then you put in smaller objects that will then gravitate towards the heavier object. That's what gravity is. It bends, something that bends time and space creates gravity waves. Now if you put something extremely heavy, it will create a tear in time and space. It will create a tear in your bed sheet. And that creates a wormhole. Now where does the wormhole go to? So there, we don't exactly sure, but then the logic of science is that it goes into a different timeline or goes into a different universe. So then we come into multiverses. Now we don't use the term universe anymore, we use multiverse because it's totally egoistical to think that ours is the only universe. Once we thought that ours is the only sun, then we thought ours is the only galaxy, and then then we thought ours is the only universe. There's no reason why it should be only a universe. There will be an infinite number of them. And multiple universes are also required to explain the paradoxes and time travel. Now again, the maths show that there is no reason that time should travel only in one direction, which is forward. The maths show that time can travel in any direction, backward, forward, up, down, diagonally, and that all time is contained at the same moment also. So the paradox is that if you go back in time and you kill your grandfather, that means you will not be born. But the point is you have been born. So how to resolve the paradox? Through the multiverse. So there will be a universe where you have killed your grandfather and not been born. There will be another universe where you might have, right now you're wearing a green dress, you'll be wearing a pink dress. There will be infinite numbers of you in just slight variations. Because the number of particles in the universe are, we have counted the number of particles. So then they have to rearrange themselves in different ways with just slight variations. So the multiverse is there. And then there's also other fascinating concepts like dark energy and dark matter. It was in around about 1920, you had Frank Hubble. He discovered that the galaxies are accelerating away from each other at an extremely fast rate, and its acceleration is continuously increasing. So where did all this energy come from? We have calculated the total amount of energy in the universe. So there's a lot of energy out there which you don't understand. And then there's also something like dark matter. There are about 27 of all the matter in the universe. That is, we just don't understand. It is dark matter. We calculated because of the gravity that's there. So something is holding the planets together, the galaxies together, and that gravity cannot be accounted for just by the seen matter. So there's some unseen matter. So coming back to time, time is extremely strange. It's very easy to travel into the future. People might have seen the movie Interstellar. So if you go, everybody's time is different. Your time and my time are unique. Your time is unique, my time is unique, everybody's time is different. Like for instance, if I'm walking, then if I'm moving, then time moves slower for me. If I'm traveling at half the speed of light, time slows down 50%. If I travel at the speed of light, time does not move at all. And I live in Bombay now, so I live on the 5th floor of a building. And time for me is moving faster on the 5th floor than for a person who's living on the ground floor. Because gravity slows down time. And there are certain, like the photons. All light is emitted by photons. Photons travel exactly at the speed of light. So therefore photons have got absolutely no concept about the duration of time. When it travels, let us say, from the sun to the earth, it takes about 9 minutes to travel here. It doesn't know that time, 9 minutes has elapsed. So time is extremely strange. And if you have an alien, an extraterrestrial intelligence, let us say about 13 billion light years away, and if he's moving towards you, let's say he's got onto a cycle, and moving towards you, then he's seeing about 300 years into your past. And if he's moving away from you on the same bicycle, he's seeing 300 years into the future. That means your future, past, and present are all contained at the same moment. Very strange, right? Very strange. But the point is true. What's the point? It is true. There's no dispute about it. So now I got these concepts and a lot of other concepts together, which have been proven experimentally, and to try to find out if there's something that can answer the mystery of death. Because quantum physics does not accept death. Quantum physics doesn't accept death. Quantum physics, the maths of quantum physics and astrophysics does not understand that, will not accept that. I'll tell you why. We are all made of particles, atoms and subatomic particles. Now the particle is very, very strange. If it is not observed, it's in a total absolute vacuum, then that particle remains in a state which is known as a quantum collapse. That means it stays in a state of infinite possibilities. This only is observed. Then it pops up as a particle of you, of me, of this podium, of the speaker, of this book. And it pops up in your timeline, in your set of 3 dimensions, and your universe. Otherwise, it stays in a state of infinite possibilities. You heard of quantum computers. It works on this principle. Normal computers they work on this binary 0-1s in a linear fashion. But here, the quantum computer, that particle, it stays in a state of infinite possibilities, and it has all your answers before you even ask the questions. So a quantum computer can solve a mathematical problem which will take a normal computer 1,000 years. It will solve the problem in a microsecond. So death is not understood by quantum physics, is not understood by astrophysics, because if there was no observation, there will be no matter. And observation requires life. So therefore all matter, that is you, me, this hotel, this planet, the stars, it requires observation. Observation, probably not only from humans, but could be from plants, from viruses, from bacteria, animals, but it requires life. So then what happens after death? So then all the other concepts like different dimensions, black holes, extraterrestrial intelligence. So that's where it all comes in. So this is a very interesting journey that I had writing it. And hopefully, if you ever get a copy of the book, you'll also enjoy it. Thank you.